So, sharks, good evening. Today, I would like to present you a new project, a new thing that will help you and will change all your life. Today, my group and I will present you an idea that will make you see the future on this life. We'll see you and we'll present you a car that will make you go faster, will make you be more eco-friendly, and will make you love more the cars. With it, the project title is the Raindrop Transport. My group and I are confirmed by Gabriela Garcia, Mariana Rubiano, Samuel Puerta, Samuel Luceche, and by me, Juan Esteban Mezquita. This is connected with the line of inquiry that it's renewable energy. This is the main thing and the main topic that will be chosen and that will be worked during this project.
Hi, my name is Gabriela, and today I will be explaining to you, sharks, the research problem of the overall project. So, initially, the problem, with hopes of being surpassed, refers to the utilization of dynamic, safe, and overall effective ways of transportation without implying an environmental footprint. This is to say safe and effective ways of moving without causing negative impacts. Even though sometimes electric vehicles do not ensure the fastest way of migrating internally, seeking for the most effective but overall green transportation method is a factor that in this project is considered crucial, fundamental, and totally vital. For example, our regular cars, the ones we use day to day, that use fossil fuels as propellers, produce approximately 4.6 metric tons of carbon dioxide per year. This is a huge and abusive amount. However, it has been proven that due to the fact that EVs or electric vehicles do not burn domestic sources of energy, they manage to reduce the impact that greenhouse gas emissions have in regard to climate change, to smog, to public health, and to ecological damage. Therefore, and bearing in mind these two factors, effectiveness and ecologic impacts, it must be remarked that in order to target these issues in question, the modification must be regarding the shape and the propeller itself. Not only the propeller should shift, but also the shape as mentioned previously. Thus, the subsequent proposal refers to an imitation of the peregrine Halcon car, the one showed here, within the shape of the car itself. This to ensure both factors, drifting throughout the air in the easiest way possible, and it being an electric vehicle that does not use fossil fuels. Mm.
Hi, my name is Samuel Seche and I'm going to be presenting the results of our investigation. Here we are comparing a normal fuel taxi against our electric taxi, and we can see that our car is almost twice as effective as a normal fuel car. Where a normal taxi consumes 100 grams of CO2 per kilometer, our electric taxi consumes 58 grams of CO2 per kilometer. Comparing our model against a petroleum car and our Tesla, we can see that in air resistance, our car is the best one in terms of air resistance, causing it to use less energy per kilometer and making, by this, create less greenhouse effects. We can also see in this next chart that our model is the second fastest. We can see that the red line represents the Tesla being the fastest, then the black line represents our model being the second fastest, and the normal taxi being the slowest. Then we can see CO2 production. The bigger the CO2 production, the worse for the environment. And in this chart, the purple line represents the normal combustion car, the green line represents the Tesla, and the red line represents our model. Then we can see the energy needed for all of these cars, where the purple line represents the electric vehicle, the blue line, that is the second most effective, represents our model, and the fuel card, which is the green, is the car that needs the most energy to move. And here we have an aerodynamic model of our car, which has a form that it's very aerodynamic and helps it to be as efficient as it is.
Pretty good, pretty good. You, nice. Right. So now we're gonna continue to our experimental design. We first measured the solar energy that was captured and transferred into voltage from the solar panels. This allowed us to in a way, picture how our efficient will be our motors, electric motors be, so that we can adjust our solar panel dimensions and our dimensions of these little DC motors so that they worked in unison. Then we moved on to the cutting the wood model and designing the shape of our car. We decided to go with a water drop style as seen on the next slide. The main work was done by our development team. They used the finest woods of every part of the world and also really lightweight, so the scale car was able to move. We made the shape of the car as a raindrop, as previously stated, for it to have an aerodynamic features. Thus, we incorporated the wheels, as seen on the picture right here. It used a single axle in the back and a powered axle on the front. Then incorporated the motors, the chairs, and also the gears as seen here. We can see the motor being a little bit higher than the transmission so that it can generate power and move it to the front transmission of the car. And that was our main body of experimental design. We use a lot of lightweight materials in this to save energy from the solar panels and also to reduce weight in a way so that the DC motors could be small and easy to fit inside the of the car. And we did all this by using plywood and some plastic wheels made of PVC that came in another car using recycled materials. And that was pretty much how we used to design the experiment.
Interesting, very interesting.
Now we're gonna analyze the data we received from our comparison between models. First of all, analyzing the speed and the velocity, it can be seen how our car has more velocity than a normal taxi, in this case a Nissan March, because it has a 4.3 kilometer per hour difference of speed. And by having a greater speed, there will be less energy consumption. And having a greater speed also means that the aerodynamics in the vehicle worked, as the car can go faster. In comparison with the energy, it can also be said that there's energy savings because our car only produces 9.36 kilowatt per hour, and an electric car, a Tesla, produces almost 17 kilowatts per hour, which means there's an energy saving of 6.64 kilowatt per hour, which is a huge difference and a huge advancement for developing electric taxis in cities all around the world without consuming much energy than a conventional car. In terms of the release of greenhouse gases, our experimental model also accomplished its main goal, which was the reduction of CO2 production. In this case, our model, in compared with a refined petroleum car, a taxi, it was saved 0.064 kilograms of CO2 production per kilometer, which is a huge difference between the CO2 production and a huge advancement for our society and for creating sustainable vehicles.
Well, now, sharks, to conclude, we would like to see and to tell you what happens with this experiment. For these reasons exposed previously, it is possible to conclude that our model is a great proposal for the improvement for public transportation in the future. This statement can be made due to the fact that the model only produces 0.0 0.36 kilograms of greenhouse gases per kilometer. A normal fuel consumption taxi produces a 0.1 kilograms, which means there is a 0.064 savings of CO2 gases per kilometer. Well, now you'll be thinking, what happens? Well, the main goal of the project was to make a taxi that reduced the CO2 production and left a positive impact for the environment. Now, taking these factors into account, it can be said that the model that was made is an interesting, we can say, proposal that allows public transportation to take a step into the future of our renewable energy vehicles. Well, now, Sharks, that we present our project is on your hands. Would you like to put your money in the future, or would you like to let this project go away? Thank you very much, and this was our product.
I like it. Yes.